Alright, let's get on into our last episode of the said tutorial. Obviously, we're not going to exhaust all the possibilities and everything there is to know about sed, but we will make it through the end of our command list. I promised that we'd cover these last 4 lines here. Let's go ahead and use our knowledge to represent those with sed. First, we'll pipe the command list as the stdin to sed, and then we'll say from the line that starts with L to the end of the file, print that, and of course we need a -n flag, so put that on there. Then we can get those 4 lines. So to start off with, the L command is really quite simple and really quite useful. It's the basic debugging command of sed. It may stand for look, I'm not completely sure. You can always take a look at the manual in here. Here it is, list. And as it says, it lists out the current line in a visually ambiguous form. I think this definition is actually a little bit ambiguous, so that's ironic, because it doesn't necessarily list out the current line so much as it lists out what's in the pattern space. You can see here that you can specify a width if you'd like. I'm not going to demonstrate that. But like I said, it will show you what's in the pattern space. So for example, let's just refresh ourselves with our poem here. And let's say I do something like, let's first use the in command, and then we'll print once. That should be fine. So we should get 2 copies for each 2 lines. It'll print the first 2 lines twice, and then the 3rd and 4th line twice, like this. We've already covered these commands, so you can kind of understand that when the in command executes, it's pulling violets are blue into the pattern space, then it's explicitly printing that pattern space, and then you reach the end of the command, so it prints it again. So let's use the L command to kind of debug this. So we'll use the L command after the in to take a look at what's in the pattern space. And you can see after the in executes and pulls violets are blue into the pattern space, it shows us right here what's in the pattern space. Of course, it uses this new line symbol and this $sign to signify the end. That's just to make it more clear. But now that we can see what's in the pattern space, it makes sense that P is explicitly printing that, and then the end of the commands is outputting the pattern space as it normally does. So it's just a little debugging tool when you're using a lot of ends and other commands that we'll get into that do complicated things to the pattern space. It's nice to have a way to see exactly what's in there just so you can debug your script. Okay, what's next here? A, I, and C are actually quite simple commands. They're similar to append, insert, and change in Vim. That's what they stand for, append, insert, and change. Except they work on a line-wise fashion instead of a character-wise fashion. So if we use poem and we pipe it into sed, let's say right after line 2, I want to append a line to say this is after line 2. And then you can see after it reached line 2, it added or appended a line that says this is after line 2, and then it continues. The insert command does just the opposite and puts it before the specified line. So you can see that this appears before violets are blue because it inserted this line before the specified line. You can use any kind of range with that as well. And the C command will change the line. So we can say this is a new line 2. We'll change this to C, and this will change line 2 so that line 2 now says this is a new line 2. So it completely removed the old violets are blue and put in this is a new line 2. So those are 3 commands to do some editing within sed. Now if you want to change an actual portion of a line or something within a line, you'll have to use the substitute command or the Y command, something like that, because these operate on a line-wise fashion. Then let's get into some of the more complicated commands. This is where I'll have to pull out Vim once again to demonstrate, because it helps to have kind of a visual way to look at these commands. So let's open up Vim. Let's see, what do we have here? Vim input. Okay, let's just delete these and we'll make an output, and then we'll also make pattern space right here. So this is our usual setup. We just covered these two lines of commands, L, A, I, and C, and now we're on X, H, and G. Now, X, H, and G are all commands that deal with a fourth and so far unmentioned piece of memory within sed that's called the hold space. So here's our pattern space up here. Now let's imagine we have another space down here called the hold space, which until now has not had any use or purpose. So this is completely new. I'm just now telling you about this. Okay, and what the hold space does is exactly what it's named. It allows you to store some information inside of it so that you can later get it back. So in a sense, in computer programming sense, it's kind of like where you could store a variable, one variable. It has some memory where you can put something in there and then later you can get it back. So I'll just go ahead and tell you what each of these commands do, and then we'll kind of go through them each and maybe have an example of each of them. So the X command, it swaps the contents of the pattern space and the hold space. So say roses are red was in my pattern space right now, and we were executing commands, and we got to the X command. What it would do is it would switch what's in the pattern space and the hold space. So now roses are red would be down here, and there would be just a empty new line here in the pattern space. It does actually insert a new line. So that's one thing I didn't really explain very well, is the hold space by default has kind of an empty line in it. So you might think of it as this, as having two lines with one blank, because so far we've been representing the pattern space as this, but there is a actual new line in the hold space, so that when you switch, for example, roses are red with the hold space, this would now become this, and the pattern space would now become this with a blank line. To illustrate that, well, first let's get through these other commands and what they are, and then I'll illustrate that. Okay. So X swaps the contents. H stands for hold, and that just puts whatever's in the pattern space to the hold space. So if I used H, we're talking about lowercase h first. If I used H, all it's going to do is this. It's going to put whatever was in the pattern space into the hold space. To make the difference of that a little bit clearer, let's say instead of having a new line in the hold space like this, I had something else like roses are green in my hold space. So when if I operated X on this, the top would become roses are green, and the bottom would become roses are red, because they're swapped. But if I instead used H, if I used H in this instance, that would hold whatever in the pattern space in the hold space. So it wouldn't swap them, it would just put what's in the pattern space into the hold space. I'm sure you understand that. G does the exact opposite. It stands for get. You're going to get whatever's in the hold space into the pattern space. So if I use G, it's kind of retrieving the value of that variable, and it's going to do just the opposite. So it would take roses are red and put it in the pattern space. And then capital H and capital G work much like in that they append instead of completely replacing. So if I had roses are green down here, and then I used a capital G, then it would append roses are green to the pattern space instead of replacing it. And likewise with H, it appends it to the hold space instead of completely replacing it. So to illustrate that, let's operate a command on these four lines. I'll use sed right here, and we're just going to use a capital G, and I just want you to think for a second about what this will do. So it's going to operate the G command on every line in the file, and what the G command does is it gets something from the hold space and appends it to the pattern space, and by default the hold space has a blank line, so this will append a blank line to each line in our input like that. So this will double space our input. Now if I used instead of G I used X, then what would happen? Well, it's going to swap whatever's in the pattern space with the hold space. So the first line will get swapped with a new line, but then after that we'll have the first line in the hold space. So when the second line comes in, the first line will get swapped there. Just to demonstrate this for you, we get a blank line and then we get the first three lines. Let's walk through that one in our usual fashion to kind of make sense of it. So first it will paste the first, or pull the first line into the pattern space, right? And then it's going to operate X. So what X is going to do is it's going to put roses are red into the hold space and swap what was in the hold space with nothing into the pattern space, right? And then we will print that output, which in this case is a blank line. That's what's in our pattern space. So then we'll pull the second line in, and then it's going to swap what's in the pattern space with whatever's in the hold space. So now we get roses are red, and that's going to get printed out. Then we will pull the third line in and swap that. It might look confusing just from the way I'm doing it, but hopefully you understand that the end result of operating sed X on these four lines is that the first line is going to become blank, and the last line will never get printed because it's in the hold space when we're done. So when we're done with everything, the vim and sed do line number 4, is still going to be in the hold space, and that's why we don't get it in the output. It never gets printed because it was stuck in the hold space. So that's pretty much all there is to know about these commands. You can do a lot of interesting things with that, as you can imagine. Like I said, it's kind of like sed has a variable or a place to store information that you can later get back. And you can kind of think of all the possibilities that that could do. Or you could choose to never use these commands and just remember capital G if you want to double space something. Finally, we have the colon, B, and T commands. These don't have anything to do with the hold space, so I'm just going to close that, and we'll keep our original 3 windows here just to try and make it a little less convoluted. We'll actually separate T off because it's a little bit different, but colon and B are how sed handles flow control. So all Turing complete programming languages have some way of doing flow control. So for instance, a function in many programming languages can be called at another place in the file, and when you get to that line that calls the function, the program begins executing inside that function. Then when it's done with that function, it goes back to where the function was called and continues processing on from there. And that's one way you can reduce the amount of code that you have to write, since you can call that function multiple times. And there's several other benefits to that kind of a feature. So sed also includes flow control through these commands. The colon command is, in a way, the command that defines the function. This analogy isn't really perfect and can't stretch all the way, but it's a labeling command. It allows you to define a label that you will later then return to, and that's what the B command does. It stands for break, and it breaks to a label that was previously defined. So that may be confusing. I think we may have more luck looking at this on the command line, so we'll do that. So if I input poem, let's use the E command we talked about earlier. It makes it a little bit easier to work with labels because it separates them out from the rest of the commands. So we'll use the colon here, just like this, and we'll make a label called, we'll just call it function, okay? Just to continue with that analogy, I guess. So now we have a label defined by colon called function. We can then continue and put in some commands, and let's just execute this for now. Why don't you go ahead and think about what this will do. It's just going to print every line 3 times, just like that. And the reason for that is because effectively all we've done is execute P twice, and there's no -n flag, so it's going to explicitly print twice and then default output. Because all we did was define a label. We never at any point broke back to a label. So we never called this function, we just defined it in a sense, if that's a decent way of thinking about it. So if later, let's say in the function, we do want to go back to the function, we can use the b command, and we'll just say b function. And then when this is called, when b function is called, it's going to go to the place where the label was defined. So what will the end result of this be? It will continue to loop back to where the label was defined. So this, in a sense, is a while loop, because it will continue just printing. It'll never get to the second line. As you can see here, it's just doing roses are red a ton of times, because this is effectively just a while loop that continues to go back. You can use these in multiple different ways. You could have multiple different labels and specify which one you want to call later. You can make loops with them. It's just a way to use flow control, and it can get complicated if you're willing to go there. So the T command is a little bit different, but has similar functionality because it also operates in a sense with flow control. And the T command is, actually I don't know what it stands for. Maybe we can look that up in the manual here. Let's see. It does not, well, there's no word here that starts with T, so I guess it's just called T because it is. I'm sorry, it doesn't have a nice mnemonic to it. But it does define what it does right here. If a substitute command has executed successfully, once the T is called, it will branch to the specified label. So we just talked about how to define label. We defined a label with colon and called it function. And this will, like the B command, break to a label, but only if a substitute command has been successful since that command was called. So in a sense, it's like an if statement in a way. I know we've already used that analogy for ranges, but it's basically saying if you've substituted successfully, then break to this label. If you haven't substituted successfully, then don't. So it's a way of saying I'm going to try this substitute command, and if it works, I want to go somewhere else, and if it doesn't, continue on. If you don't specify a label with the T command, it will just, B stands for branch. I say break. It's kind of the same idea, but if there's no label specified for T, then it will branch to the end of the script. And then here's a little freebie. Capital T does the same thing as T, but it's if it's unsuccessful, if no successful substitute has happened. So it's the same if statement, but with a not in front of it. So it's the opposite. If there hasn't been a successful, then it will break. Wrap your head around that a little bit. Here's another command we didn't talk about explicitly. Capital W will just write the first line of the pattern space, kind of like capital P only prints the first line in the current pattern space. Capital W will only save the first, or write the first line of the current pattern space. I think there's one other command in here that I neglected to mention, which is capital Q. So with lowercase q, like I said before, it immediately quits the script. but it will print out the current pattern space, whereas Q will immediately execute the script and not process anything and not print anything out. So if you finish with Q and you don't have the -n flag, then it will go ahead and do that last printing of the current pattern space. That's why it says if it's not disabled, it means you don't have the -n flag. Whereas Q will just quit and it's done with it. Okay, I think we've covered most everything in here. There's there's one other thing in here with the substitute command. Let's see if I can find it. Basically, well, it may be further down. That's the problem. Here it is, right here. Here's a couple other things I didn't exactly mention with these regex forward slashes. When you want to match a line, you can use any character you want if you append it with a backslash. So I could use like backslash and then use the bar symbol or something like that, the pipe symbol. If you had a regex that had a lot of forward slashes in it, that could be useful. And then for ranges, I also didn't mention this +n. We talked about +n in Vim, how you can append it to the end of either side of a range, or -n to either side of the range. But this works a little differently. This just adds whatever many number of lines to whatever the first one was. So, and then the ~n does it until the next line whose input is a multiple of n. I don't know when you'd use that unless you're doing some really complicated stuff. But just to drive that point home, let's have an example of that. So here's said with nothing in it, and let's say I want line 1 and then 2 lines beyond that print, and we'll use -n so that it doesn't print anything else. Then I'm just going to get the first line and then 2 more. And you might be thinking, well, that's not very useful. But if I was using a search pattern like this, like say I searched for blue, then I can do blue plus 2 lines. So in that case, you don't have to know which line blue is on. You still want 2 lines after it. And for that other thing I was talking about, let's use the pipe symbol with a regex. As long as you append it with a backslash, it should work just like that. Alright, so I hope you've enjoyed this series. I hope you've learned at least one new command you didn't know about sed. Make sure you look into the manual. As we have been doing in this episode, there's also a ton of resources online. You can look up people who are solving Sudoku puzzles and doing calculus if you want to get to that level of sed. I personally don't. I just think it's a really neat little program and wanted to do this series to kind of share some of my fascination with it. And I hope that you will subscribe and like this video if you enjoyed the series. Let me know with a comment, or you can comment here on YouTube or on my website. And stay tuned for more Unix videos. Thanks, and hope you have a great week.